Welcome, everyone. Thanks for joining us today. My name is Cecilia Lee. I'm an editor-in-chief at the International Society of Service Innovation Professionals, known as ISSIP. And I've invited two ISSIP ambassadors who are thought leaders in digital twin, Sean West, professor at Luzern University of Applied Science and Arts, and Antonio Padovano, assistant professor at the University of Calabria. Thanks for joining us, Sean and Antonio. So lovely to have you.
Thank you. Thank you for inviting us.
So before we deep dive into your talk today, Antonio and Sean, would you like to introduce yourself to our live audiences here? Antonio, would you like to go first?
I go first, or Sean, please.
Just a quick introduction before we deep dive into, deep dive into your talk.
Okay. So thank you. I am, as you said, assistant professor. I'm Antonio Padovano, assistant professor of industrial system engineering at the University of Calabria, specifically at the Department of Mechanical Energy and Management Engineering. And I have a specialization in management engineering and industrial operations design and optimization. And I'm very glad to serve as ISSIP ambassador at the International Conference on Industry 4.0 and Smart Manufacturing. It is this great, event that is held every year in different countries, right now located in Europe, that brings together researchers and scientists in the area of Industry 4.0 and especially digital twins.
Amazing. Sean?
Sean West. I work at the University in Luzern. I spend a lot of time working on innovation around product service systems and operation of product service systems, which is why I find digital twins really very, very useful. What I realize is a few years ago, when I was still living in the UK, we were using digital twins to help us improve the performance of our power stations. And we had different approaches that we were taking. So seeing that now come into more general usage is actually quite cool. My background, personally, I've worked and built service businesses up. I've spent most of my time working around service and operations environments and trying to integrate the technology so that we can actually make something useful with the technology rather than just have some cool technology. When I'm not here, I spend a lot of time running, skiing and climbing in the mountains, which is why I ended up in Switzerland.
Amazing. Thank you, Sean.
Thanks.
So we're going to move on to Sean and Antonio's talk. For our audiences, after Sean and Antonio's talk, we're going to open the floor and then take some questions from audiences too. Mm-hmm. So Antonio, would you like to go first? I can just put up your slide here.
Okay, in the meantime, okay, great. Good. So thank you, Cecilia, for sharing the screen. Actually, this slide would like to be a one-page picture of some interesting things that I would like to discuss with you today. So first of all, I believe that the picture on the top right corner gives you an idea of what digital twins were in the past. So, because what is a digital twin basically today? It's some kind of tool that we use in a way to collect the data from the real systems, to analyze such data, to create some augmented data to understand better in a more transparent and visible way, which are the processes of the system under study, and then to feed back, to act back on the system that we are controlling. And this is a nice picture because especially in the, let's say, war rooms in the past, you have to think about, for example, the old guys in the room that they were managing the fleet of ships moving around a lot of oceans around the world. And they were receiving over the radio the position in real time, or at least almost real time, the position over the radio of the ships. And using always the radio, they were used to give instructions back to the people on the ships and to the captain. So this is some kind of really old concept reinvented. And what we are actually doing today is to use the technologies, the digital technologies, and the empowering tools of the Industry 4.0 to apply this approach in our daily life, from our smart homes to our industrial systems and manufacturing systems. Well, my research is explicitly focused on human-centered systems, on human-machine symbiosis, human augmentation for a smart workforce. So when we think about the digital twin, we always have to remember that it's not like a way just to augment the capabilities of physical systems, but also to interact in a novel way with such systems, with the physical systems. And to do so, I would like to also raise some comments about the traditional confusion that we have between digital shadows, digital models, digital twins. So if you look at the literature, you can see a lot of people, but even when you get in touch with the companies to develop some prototypes of such tools, such solutions, there is a lot of confusion from this point of view, because they are really willing to move in this next stage of the digital transformation. But of course, it's a very, very long process. And what we have to remember is that a digital twin is like a very complex and composite tool, which goes from creating the digital models of every tiny piece, every tiny component, and moving, thanks to the integration of all these components, to more complex systems of systems. And therefore, with this approach, considering always with the scope of the digital twins in mind, we have what we usually recommend to the companies is to start from a minimum viable product. So to start simple, and then develop step by step such solutions. Of course, let's say when we focus on the value and on the digital transformation of the business, I believe that this is where actually we should focus on. So it's not just a matter of creating digital twins for the technicality of it, but because we actually have to drive businesses, drive organizations in a new era, in a new stage of their life. And this is really, really difficult because there are no methods, no approaches today to evaluate which is the actual value of a digital twin. So if you talk to managers, if you talk to consultants, we all agree that, of course, we can achieve some improved costs. We can enhance maintenance because probably we do some analysis in a very predictive and prescriptive manner. We can increase safety. But on the other side, when we start developing some prototypes in practice, it's always very difficult to analyze. And this is some kind of barrier for managers who have to put some money, some investment money in research projects and research and development of their own business in this perspective. And also, let's say, if we are not talking about just digital shadow, digital models, digital twins, and all this terminology, what I would like to also consider is the importance of the digital thread. What is the digital thread? I believe that the picture on the bottom right corner gives you an idea, like the kids playing the game of the telephone. You remember when we were a kid, most of us used to play to this game. It's a way to share data, share information from the very beginning to the end, to the last stage. So, and the message should always be the same, should never, be different between all the guys and all the girls. So, which is the concept here, is that going from the design stages to the, let's say, to the end user that is actually exploiting the product, we have to create digital twins that are able to connect all the steps of productions. And this is also very challenging nowadays. So a lot of research is being done in this sense, especially in terms of interconnectivity, in terms of interoperability and standardization of digital twins. And finally, one last comment I would like to give you is regarding the fact that the digital twin is usually considered as a living entity. We used to read a lot about the fact that the digital twin is a living entity. But as a living entity, since it's a living entity, we have to think about the birth, but also the death of a digital twin. So my question is, can a digital twin die, for example? So it's not just a matter of the death of AI or some kind of philosophical question like this, but it's a matter of creating prototypes that are not focusing on just a case study. So we work a lot in the area of simulation, and we are used to develop a lot of simulation models in collaboration with companies that ask us to do some analysis. But these kind of models are usually very focusing on case studies. This is a problem because, of course, it's a lot of work that every time should start from scratch and again and again and again. So we are not able to create some sort of tool that is able to, let's say, be expanded to be more generally applicable to different cases. So every time, still, every prototype should be created and developed from scratch. These are just some comments I wanted to give for you, and thank you for your attention. I would be glad to talk to you more about these aspects and to also know your comments and feedback.
Thank you, Antonio. Let's move on to Sean's presentation.
Cool. Thanks, Antonio. That was really cool. Oh, sorry, I've just lost the screen now. I haven't got enough screens. I'm trying to share my screen, but it's not showing. Sorry.
I'm sharing it. Can you see my screen now?
No, I can't.
You can't see my screen.
I've just managed to do something.
Oh yeah. Would you like to share yours then?
Up as a separate space. Sorry. Hang on. We should be able to see. Oh gosh. Yeah. Wrong button. There it is. It's on desktop too. I'm using. Oh, a little bit of lag on here. Thank you. If you could pop the slides up, that'd be cool.
Okay, let me just do that. The one that you share with me, and share my screen. Oh.
Right.
In a second. Where is the Sean's slide deck here? It's over here. Open. There we go. Can you see my screen now?
Yep. If you could start from the beginning, that would be cool. Okay, cool. No, there we go. I just want to start on that side because it shows to me people, machines, and robots all kind of working together. And I think that's a thing which I think is important for me when I think about the digital twin. It's not, we interact with it and it has to interact with us. So how does all that happen? If you go to the next slide. That kind of carries on with what we just heard from Antonio, that we don't really know what it is. Yes, we do. No, we don't. Yes, we do. Yes, we do. No, we don't. There's lots of questions. Somebody told me that BIM was a digital twin, and I'm going, well, it's a good digital artifact, but it's not a digital twin on its own. It doesn't allow me to do things. It's not just about collecting data. It's not just about having an archive. It's a whole bunch of things. It's about playing with future scenarios. we heard about what the benefits were. A lot of benefits I've heard are associated with we can make a better machine. I prefer to say we can actually make the operation of our plant better, and maybe we can improve the machine performance better as well. There's always some implications. If I make a better machine, I potentially create a competitor for myself. So we have to be very, very careful about what we are trying to do and what we think the real benefit of this machine is. And going back to the modeling, I've got to say, I still quite like Excel. I'm kind of old-fashioned like that. I find it's a very useful tool for me. It allows me to know what's going on. In fact, we just finished a project, or finishing a project with the ISSIP, and we started with an Excel model, and we validated it, and then we kept moving on and moving on. So if you can move to the next slide. We spoke a little bit about value and why value. Value is what we do, and we've done some work, and I'm going to challenge Antonio here to say that we've actually come out with some indicators for value based around service dominant logic, and we based this on 20 use cases plus. It's the mapping, not of all the components within a life cycle using physical data, virtual data, and the interactions between them, for the production from different perspectives. And I think the different perspectives here is really how we support value co-creation. The table on the other side is things, key characteristics that we must consider whilst we're building a system. Part of it is, how big does the box have to be? I don't need to have every atom as a digital twin. What's the unit of analysis that I'm taking through that? We go through, how do we build it together? I want it modular. It'd be kind of crazy if the internet wasn't of a modular design. So why do we want to have a complete, simple box that we put everything in? Because it isn't going to work. Value co-creation. How do we help people collaborate and work together? How do we accommodate different roles? Anybody like me who's frustrated with SAP will understand this. And if I use SAP in different ways, I can get some of the attributes of a digital twin. But if we go to the next slide, I'm going to show you what I think is one of the best digital twins I know. Google Maps. We use it every day. I actually used it to get here to the university at Bournemouth. I just put the address in, it told me where I was. It knows the conditions on the road. It also got a forecasting engine in there that says, well, this time on a Friday, everyone's going home. So the road's chock-a-block. And it told me where I was. And it also, what I really like, it supports the decision-making process. It tells me how I could get there. I could have walked, but I had a big bag with me, so I wasn't going to walk, so I decided to take an Uber. And it told me how long I was going to take, and it told me when I was going to get there. All things in the future based on stuff in the past. And this, to me, is a really, really cool example of a digital twin. If you could go to the next slide, please. IBM, pumping solutions. I know pumps. I used to work for Salter, so I know pumps quite well. And we had a lot on a power station. To me, this looks like a power station. I want to know how the pumps are working. Are they moving the amount of water that I'm expecting them to? If not, why not? And it's if not, why not is the really important thing about the support that the digital twin provides to us. And I think we have to bear that in mind. It's helping us to do things. And what I really like about it is some of the visualization. It looks kind of real. It's not just a HMI that you have to have 20 years worth of training on to work on. Now, I've seen that. I've seen a Honeywell 1970s HMI, and it's horrible to use, but the guys were used to using it, and we had to create a mimic for it. However, today we can create stuff which actually works on these things, mobile phones and all sorts of devices, which change the way we work through it. What I will say is, please don't ask me to use HoloLens to do it, because I will throw it out of the room. It's not a very good advanced approach. Can you move to the next slide, please? Azure. Now, this is why we need it modular, because we can create a whole city. And at the moment, I'm creating a whole train network with Eugen, who's on the call with us. And it's really difficult. And you have to work out what is the correct size. Now, what you will notice in a city, you have people like me that think they know where they're going, but haven't got a clue, to be perfectly honest. You have to deal with me, and don't ever deal with me as a user. I don't use a city. I travel around the city. I go shopping. I do many, many things. How the heck do you manage to integrate me within that system? Because I am slightly chaotic. I'm slightly random. and I will do things that you don't expect me to do. On average, I will do what you expect me to do. And that's something which I think we have to deal with, is the probability effects in that. And we have to be able to have a normal computer be able to manage it, not a quantum machine. Go to the next slide, please. Going back to an industrial setting, we have lots of opportunities to help people make better decisions and take better actions. This is where I think digital twins really, really supports. What are the questions that these people are asking? What form do they want to consider that in? How do they make decisions? We need to integrate with them and challenge them as well, which is tricky. And that means that we really need to consider the actors, the roles and situations, and not just say the user needs to do this. Like I say, I am the weakest link in any process. Okay, I can break anything. I can go the wrong way. I got lost at King's Cross Station because I know King's Cross Station really well. Wrong. I remember knowing King's Cross Station 20 years ago really, really well, and they've dug it all up and they've rebuilt it, and I haven't got a clue. So you have to build that into the way that we'll interact with it. I think that interaction isn't trivial, and we really do need to prototype that, as Antonio said, very, very early. If you could move to the next slide, please. What I really like about digital twins, and this is kind of the geeky side of me, is that we take the data, we somehow shape it into information, and then the magic happens. People start talking about it, and we start to really build knowledge within. Why does that happen? It's not about AI, it's about people working stuff out with the aid of AI and machine learning, and sometimes just some very simple visuals. Why it's happening. And we can embed that as wisdom within the firm. Now, I know this is the case because at SBB, they have some people who, I don't know how they do it, but they can schedule trains. They've eaten the book. And they can say, oh, there's space here and here. I'm trying to model that. It's almost impossible. Although that's what we're trying to do at the moment because we think it's fun. And we think it's worthwhile. Now, how do we put that together? Now, how do we do that? So there's a real interaction over time as we build upon that. And I think that's something that's really important. Next slide, please. So I'm using some German in here, Mitarbeiter. Sorry, this was a German presentation. Sometimes I want to use the digital twin to control something. Please keep this room between this temperature and this temperature, and digital twin and go away and do it. And report back to me if something goes wrong. So I'm empowering that digital twin to be a co-worker with me, a cobot, if you like. Sometimes I want it to say, hey, Sean, you're doing something which mightn't be the best thing to do. At which point I can argue with the robot or the machine, or however we're arguing with it. Sometimes I want it to tell me what the implications are of not doing something. Because I know stuff which is outside its boundaries. I know stuff which is going on outside of its world. And I think that's an important thing. That's why I don't agree with Porter about autonomy and optimization and control. I don't believe that that shows you how value is created. I think he's wrong there. I think it shows different layers of interaction and different layers of system boundaries, which are very, very important. And at the end there, I said that the digital twin here can also be a teacher, which is kind of cool. Next slide, please. Value is created. You have to click through because the build doesn't work. Sorry. Value is created when actions are taken. So I really want to say what happens if we do that. So we're going to go back one. Brilliant. If you do this, if you do this, if you do this, a consequence. That's what I really want. I want to have a dialogue with the digital twin. Maybe I'm talking another 5-10 years in advance, but I want to argue with this computer. And this comes back to me probably watching too much science fiction as a kid. I used to watch it all right. If you do that, this will happen. Well, good. Well, help me. And I think that's really, really important. This is how we get interaction. This is how we learn stuff. This is how we create new stuff. So I think it's really, really important there. Next slide, please. Next slide.
Oh, this is next slide now.
Oh, no, jump one. Sorry,
Jump one.
should be on 11. Stupid thing. There's a bit of a lag.
Is it? I think this is the next one, Sean.
That's it, yeah.
Yeah.
That was it. Sorry about that. Where do we have opportunities for? I've called it smart services. Where have we got this opportunity for advisory? We've got it across the whole life cycle. We develop, manufacture, commission, operate, maintain, upgrade, and decommission. We also do a whole bunch of other stuff. And we have many, many people. And this is what I like about Antonio's work, and this is where his and I work, I think, really comes together. As built, as commissioned, as used, as abused, as maintained, as upgraded, as destroyed. And this means that a digital twin has to have a life cycle. I'm talking about assets which last 100 years. That's kind of interesting in IT environment where they think 3 years is a long time. Really, really interesting. Next slide, please. This is a little sketch that we built for aero engine manufacturer based on the discussion. So this is trying to operationalize it. Where do we want to be involved? How do we want to be involved? What decisions are being made? And what level of detail do we need? Actually, the turbine blades are really important. I want to know the life cycle of those in case one of the metal flies off and I have an insurance event. So there's real reason for having the digital thread in here. But how does it work over the life cycle? There are many, many perspectives, and we really, really must, and I can't emphasize it enough, take different aspects. Next slide, please. You can read our research, or you can read this handbook. This handbook takes you through the process that we've had for conceptualizing digital twins, which Jürgen has been using to actually create a simulation which will become a digital twin of SBA's railway system. If you take the QR code, you can find where to get the book, which is why the QR code is there. So thanks for your time. Thanks for listening.
Thank you, Sean.
Thanks.
So now we would like to open the floor and take some questions and then have some discussion time.
Great.
Any questions from live audiences here? We had a question from Jim, right? Jim for...
Yeah, I'll go ahead. Yeah, so this is a question both for Antonio and Sean about tech for good and digital twins. And I put it in the chat with some maybe ideas, but Sean, Antonio, when I was listening to your presentation about digital twins, I was thinking about maybe the city digital twins that help with cities might be an example of tech for good. And Sean, when I was listening to yours and that great example with Google Map, I was thinking about emergency response and disaster might be a good example of digital twins for tech for good. But let me ask each of you in turn. So Antonio, when you think of tech for good and digital twins, do examples come to mind?
Well, Jim, you touched a very, very interesting point, because the discussion about the disaster management is one of the major points of our latest research. In particular, when we talk about tech for good, I think that we are talking about technology that helps people, helps to take on big societal problems, no? Like I'm saying, aging, for example, or the importance of building communities. So from this point of view, I can see, for example, the capabilities of digital twins to help, for example, human-robot collaboration in smart factories. You know, in the last weeks, in the last months, we have been focusing on some research studies on value-driven technology development. So, are we able to design technology that also reflects our human values? Our values of, ethical values that are coming from our daily life. On the other side, I really like the idea of digital twins that Sean mentioned. A digital twin is a teacher, you know. I'm not saying that we as professors should be scared to be replaced by some digital twin or ChatGPT or any other type of tool like this. But digital twins are an incredible opportunity for education. No? Think about, we recently published a study on how digital twins can help, especially people and training people in non-routine jobs, like the case of accident managers for low probability but high impact events, like climate accidents or natural disasters and so on. So would it be possible, for example, to train workers for what is exactly coming, instead of preparing them to face a large set of scenarios like we are doing today, because we are doing classroom, we are checking all the possible, all the opportunities, all the possibilities, preparing people and giving people a lot of concepts that maybe they will never apply. Thanks to digital twin and the prediction capabilities of today, we are exactly able to predict what is coming. If I have to change a component in the aircraft engine, I know exactly which component is going to fail and what I have to do to replace it. I know the data, so and so on. So a digital twin can really help from this point of view.
Thanks. And you, Sean? Tech for good examples?
Tech for good. I think that needs to start with student education and really getting engineers to understand ethics in the programs. I think that's a basic thing. They don't understand why it's important. Technology is kind of neutral, but you can make an atom bomb or you can make a power plant. So how can you use it for good? And I'm going to pick up on a disaster situation or a negative situation of training people. So I think that's a good example. With a railway operator and a mobility OEM, we created a digital twin, and it was to do with pumping water out of the tunnel. And the snow comes in on the trains and it melts because in the tunnel it's hot. And you can model all of that. You can see how big the sump's going to be. But really the important thing was we could set up a simulation of an event that might happen once in 60 years. And we can train the people, the operators, on what to do. And so you actually build out stories for these people on what to do when this happens. And I think that's a very cool thing because you're interacting there with a digital twin. And it's teaching you. We used to use this on power plant operation. And I will go back to Star Trek. Kirk, there was a Kirk example where he beat the digital twin, which was a simulator of a starship, by breaking the code. And that shows that you shouldn't break the code. That you need to keep some separation between the people that have been trained by it and the people that have coded it. And I think that's kind of useful as well because people use it differently than you anticipated. And you need to learn from them as well. And I think Google Maps is a great example to learn from. There's so much I can learn from it. And I saw one guy beat Google Maps by pulling, I think it was 1,000 mobile phones in a truck behind him around Berlin and created a traffic jam in Google Maps. So there's ways that you can play with it as well. And I think that also tells us more about ourselves and what we can learn from things. What I think we should be careful about, and we've been doing some studies at the University of Zurich, is really ethics around digital though. And I'm coming back to that, of what you should do and what you shouldn't do. I think in some respects, we have GDPRD in Europe, which is very good because it protects workers. I can overwatch a worker doing something and say you haven't been busy and fire you. Or I can use the information to supercharge the workers so they actually make the right decisions. Now, which one do I want to be? Having read 1984 Animal Farm and all sorts of other horrible books, I prefer the other one where we actually give the technology to the people in much the same way that we do in Lean to help them get their job done better. And that to me is a way of actually making more value from the digital twins rather than using it as a policeman. I've seen somebody offer to use digital as a policeman, and I suggest we better not do it because it sets the relationship up wrong. Does that answer that question, Jim?
Yeah, thank you very much. And I see Christine Oyoung had some questions about security in digital twins. So I don't know if Christine can ask them, but you can see them in the chat.
Christine, would you like to ask a question directly to Sean and Antonio? Oh, okay. I think Christine.
Yeah, here. Yeah, sorry. I'm trying to find the button to unmute myself here. Yes, actually, thank you both Antonio and Sean for such an interesting introduction of digital twins. And then certainly, I think it's interesting to see how, you define digital twins. So maybe I can ask you, Sean, because in your slides, you gave some examples, right? But then for those examples, in my view, this is just my humble view, right? I would think they were robotics or AI rather than digital twins because they're physical, right, versus digital. Of course, in order to make them smart, they need to have the digital twins, whatever the information, in their head, in the robot's head, right? And then also, and I also agree with you, the Google Map is a digital twin. But then in order for us to really leverage it, we need to, access the Google Maps through a phone, through a computer, through a tablet, right? So can you please elaborate?
You picked on something which drove
how
me
broad
nuts.
or how narrow that you actually define digital twin.
I tend to use the term smart twin a lot of the time because I've had arguments with colleagues of mine. Oh, you haven't got enough AI or machine learning in it. Don't necessarily need that, I don't think, unless you're looking forward, really trying to make decisions. We did a study on whether academics and practitioners were agreed on what a digital twin was, and the answer was pretty much not. And that's why I come back. I'm reading one of my slides of a real-time dynamic, allowing simulation and forecasting to support decision making. I'm quite happy with the digital twin and having to access it through my phone or through my watch or through a laptop or through a screen. I think we shouldn't get too hung up on what the interface that we interface with it on. How it works, I think there's some key aspects of what it should have in there. The pump example that we've got is a digital twin. We used to have a performance digital twin, but it was more a simulation. And I think for me, the biggest question is, when does a simulation become a digital twin? And when is it just a simulation? How divorced can it become? And this is something we've been working with railway companies. Railways don't change very much. So you don't have to have 20 millisecond data coming in. What's the right granularity of that? And we said we need to make sure we know when it's changing. And for infrastructure changes on a quarterly basis as far as we're concerned. So as long as our maps for the system are synchronized by a monthly basis, we're good. Google Maps, on the other hand, is it better be real time and historic data all the way through it. And I think Google Maps is a great example. SBB made one for the phone to tell me what was happening to my train, and it really wasn't an interactive process. And maybe that's why I use the term smart twins. I want interactive with it. I want interactivity through it. Why do I want that? Because I think once you get interactivity, you get into interactive design, you start to learn stuff. The experiential aspect teaches you things. And I think that is an important thing. Does that kind of answer that?
Yeah, Sean.
I can give you about 4,000 definitions because we do have 4,000 definitions.
Yes, I do understand that, but I appreciate that. With the last comment you actually said, it's really the interaction part of it, right? So that kind of goes back to what Antonio said in the beginning, because I was also intrigued by his thinking around digital simulation, digital model, and digital twins, right? So, so for a digital twin, maybe it's more of a holistic way of really, encompasses the digital simulation, digital model, and the interaction part of it, right, as well, right? So I don't know. I mean, Antonio, do you have more thoughts along that line?
Well, regarding the security concerns, I believe that the digital twin by itself is not enabling new security concerns, new harms, but it actually because all the technologies that the digital twin is built on already have some security concerns, because of course the digital twin is like a composite system of sensors, of actuators, of robots, of tools for networking and data sharing. All these technologies have privacy concerns, security concerns. So I believe that we still have to do a lot of work, especially in terms of standardization, in order to understand which are the technologies that really enable a digital twin. Because when it comes to security, we have to focus on what's at the basis of the concept. The digital twin is just an umbrella term.
Antonio, I'd just like to carry on that. Some of the data that is collected within the digital twin, or with any digital system at the moment, it has huge amounts of commercial value in that moment, in that month, in that quarter. But after a couple of years, it's kind of so what? There's other instances where I can build up a model of the system and I can build an effective commercial digital twin. And I can say whether they're being productive or not from being how much mine equipment they're using and how much consumables they're using, etc. And I can tell you whether that mine is being used or not and how heavily it's being used and what its production is looking like, which may in some countries be a state secret. So, there's different things that we really have to worry about, because some of the proxy information that I can gather from what's actually going on can actually be really, really valuable. Yeah, I have some other stories of things which we could discuss, but not private, but not publicly.
Okay. We have another question from Jim here. Who owns and maintains the digital twin? As Antonio mentioned, if a digital twin goes away, dies, who might be harmed? Antonio, do you have an answer for this?
Well, it really depends of what are we twinning. So we are building the digital twin of what? So I believe that, this is also a nice question about answering some kind of digital twin governance system. So because of course, I believe that the digital twin should not be owned by maybe the software house who is integrating all the solutions and the systems being used for the digital twin. I don't believe it's the correct way to assign ownership of the digital twin to the system that we are actually twinning. So imagine if we are building the digital twin of a physical production system, of a manufacturing process, or of a factory, should it belong to the company itself or not? I believe that it implies a lot of questions about what the digital twin also enables in terms of implications, in terms of also value for, it creates value for who? For the company itself, for society, for citizens, for the governments, for nations. So it's really a big question.
I like what you said there. I was sitting there thinking, who owns the internet? Same type of question, who owns it? And when it's one clear factory with a production, it's very clear that factory should own it because it's part of their asset, it's part of their knowledge of operation. But on a wider side, it's kind of a little bit different. And that's why I was thinking about who owns the internet. And I think that's actually part of the thing. As we expand, particularly to smart cities, who owns the digital twin for the smart city? I would argue that this comes back to the modularity in design and making sure bits are able to exchange, but you don't have to exchange. So I think there's some real, comes back to ethics again.
Yeah. And just to say another comment to answer another question I can see in the chat very quickly. In particular, there are many companies that are interested in digital twins. For example, in our case, we are working with some companies in the oil and gas and the automotive industry that are really willing to develop digital twins. Their understanding is that a digital twin is a simulation model. It is not, of course. No. It's some kind of bundle of technological tools interoperating with each other. But when we also go very much into the matter, especially from a development point of view, and what is a very, very big barrier in the development is the fact that there are tools and equipment in companies that are not able to talk to each other. So
Yep.
interoperability issues are, it's really one of the major issues to solve. And from this point of view, again, standardization, I think, is the answer.
Thank you. One more question from Andre here. So digital twins have been adopted by service sciences. I can see. What is the quality of service with and without digital twins? Sean?
I'm going to answer that then. To err is human. To really mess it up requires a computer. You can really get it wrong if you don't understand and calibrated your twin, and it's built on the wrong basis. And this is kind of what Antonio was saying about some of the data flows that you have coming in. And the simulation model behind it has to be really, really good. However, that said, we used it to work out where to site service stations based on a particular project. So we actually took one project with the tunnel. We took it from where do we put the service station? What should the call out be? How long should it take to get there? How many spares should they have? What spares should they need? And we've also done that with something as mundane as photocopiers. They use a lot of consumables in some countries, which are very long and thin. Trying to work out where to put your materials and where your materials actually are today and where they need to be tomorrow is actually very difficult. So actually creating a digital twin of that flows and the demand flows process and really connecting it as closely as you can with the actual operational data. Create something which cuts cost out. We did take cost out of the business and we improved service quality, which was kind of cool. So you cut cost out and you improve service delivery.
Antonio,
Okay.
anything to add? Antonio?
Well, I believe that Sean already told everything about this. So again, it's really hard to, when we talk about the quality of service, we really need to understand, to define things. For people, especially with an engineering background, we are used to give definitions and to define with metrics, indicators, and numbers, everything. So when it comes to the quality of service with and without digital twins, it's kind of interesting, especially to understand what service we are talking about. So it's some like Jim previously said, it's some service because we want to build some tech for good. So of course, which is the value added of digital twins in building technologies in these directions, considering the value-driven tools and so on. So I believe that behind the digital twin there is really some value and some additional value and additional quality of service. But we need to have a perspective over the technologies that are the foundational components of this new concept.
Cool.
I'd just like to add to that. I think I base a lot of it around questions. What type of questions do we want to know answers to? And I think that helps give us an indication of what good looks like. Because if we can answer those questions with digital twin, we can improve things. I think some of the metrics that we're using are probably wrong at the moment, but as I used within operational excellence, it's good to try and measure some things, but you have to be skeptical whether they're the right KPIs, which comes back to questions. What are the questions that we're asking and we want solutions to? My question to Google Maps today was, how do I get from here to there? And it gave me guided directions.
A very interesting comment that Andre is putting in the chat is that digital twins have to be trusted, because we are building digital twins to monitor and to optimize systems, But a question I was asking myself is, should we also monitor and optimize the digital twin itself? So should we create some sort of digital twin of the digital twin, Because do we really know whether the digital twin is working properly? If it's accurate, allows us to do good predictions. So we really need also tools to monitor the effectiveness and the accuracy of digital twins themselves.
Yeah, Antonio, I think that's a good comment. In 2001, HAL misbehaves because it hasn't been told everything, or it's got conflicting requirements in there. And I think that's where we're actually very good at dealing with conflicts. The digital twin provides different solutions and tells us what the consequences of those solutions are. And I think that's the difference between people and machines at the moment.
Yeah.
Well, I know that time is up, but I have one more question for Antonio and Sean. So nowadays, digital twin is increasingly adopted by healthcare sector as well. And Sean mentioned that digital twin can be teacher. Then digital twin can help us to build a healthy lifestyle as well. Is it possible from your point of view? I mean, that touched up an ethical side as well, right? Tech for good and ethical side.
Sean, want to go first?
Yeah, I was just thinking about that. Yeah, why not? I do some running. I want to get a bit better on running. I eat probably the wrong food. I eat too much, and I don't exercise enough. And actually, I have a trainer on here from Garmin that actually tells me whether I'm going to get to my time or not, and what I should do. I think it wouldn't be a bad idea to have a digital twin and being able to understand where I fit against where I want to be. And it's quite funny. It comes back to what are your goals again? This was very funny. This was on BBC Radio 4 last night. So I don't know whether you were listening to that, Celia. And that made you think of that question of having a digital twin.
Sure.
You did as well.
Antonio, anything to add?
No, just one very quick comment, because I don't remember, probably Jim was mentioning before that digital twins allow us to understand better based on the data of the past and data about the present. I believe that we are missing something here, because of course we are using past data, like in traditional machine learning models and something like that, to build what's in the future. But at the same time, we are also missing that, I don't know, I would call it something like a creative component, something about the future, the so-called data fusion. You know, when we say that we are using data fusion because we want to merge past data, present data, future data, simulated data. But in this equation, I believe that we are missing something. That is probably also the importance of people in this, some kind of cognitive way, or cognitive human-machine interfaces and human digital twin interfaces. The human component is still, disregarded a lot of times, but it's very important also indeed to move forward with this thinking.
Antonio, there used to be a thing on financial adverts when I was living in the UK. Past performance is no guarantee of future performance. And I think that's something to bear in mind. And the digital twin has boundaries, and we have to be aware of what the boundary conditions are and where they actually lie. Because if something happens outside, then we're completely lost. And the best example of that was the spreadsheet simulations of futures, insurance futures, and in the insurance market and the mortgage market in 2008, when we nearly ran out of cash.
Cool. Thank you. Thank you so much, Sean and Antonio, for sharing your perspectives and use cases of digital twin. And also thank you so much for joining us, our live audience this year. Thanks for tuning in, and then I hope to see you guys all soon. Thanks.
Thanks.
Bye.
See you soon. Ciao.
Thank you.